Hello, my name is Srinivas Vivek. I'm an assistant professor at IIIT Bangalore since January 2018. Uh, the lab that consists of myself and my research students, we call our research group as Applied Cryptography Research Group. I'm a cryptographer, and my interests are mainly in embedded security and cloud privacy. So, in embedded security, we work on mainly protection of cryptographic implementations against side channel leakages. And in cloud privacy, particularly focus on uh, a cryptographic primitive called homomorphic encryption that allows you one to compute on ciphertext meaningfully without actually decrypting it first. And this has a lot of applications in cloud privacy. And we mainly focus on the applications of homomorphic encryption to the real world problems. Currently, I guide uh, three PhD students and one MS research students, and then a couple of undergraduate students.
Thank you, Professor Vivek, for the introduction. Myself, Annapurna Valiveti, research scholar from IIIT Bangalore. I am working with Professor Vivek on designing side channel countermeasures. I'll start my talk with a brief introduction to cryptography, the various tools offered by cryptography, and also the possible applications. Then I'll motivate the need for secure implementations, followed by side channel attacks. I'll conclude this talk with a brief discussion about my research progress at our institute. Consider this scenario where Alice and Bob would like to communicate across web. Alice is sitting somewhere in the world and Bob is sitting somewhere else. So they would like to communicate over the web. There is a communication line between Alice and Bob, which Eve can eavesdrop. Eve also can listen to the communication. Alice is running her computations on a machine and Bob also running his computations on a machine. Now, if Alice wants to open a website over HTTP, if Alice is using the communication line over HTTP, many of you must have seen this error while opening a website over HTTP. Your connection is not private. Let me try to explain what this connection is not private, what it means. If you come back to this scenario, Alice is sending her data over this communication line to Bob over HTTP, meaning Eve also can look the communication and he can understand the data being communicated. Suppose if Alice wants to communicate only with Bob, she doesn't like to share her communication with anybody. It's a private information to her which she would like to share. How can we avoid Eve not to understand this communication? This can be possible when Alice communicates over a HTTPS channel. S stands for secure. If Alice uses a HTTPS channel, she can communicate to Bob and Eve will not be able to decipher the communication. So how is this achieved? When we say HTTPS secure, meaning Alice and Bob somehow agree upon a text, a string of text, which we refer as a key. So whenever Alice would like to send an information to Bob, she essentially is locking her information in a secret box and locks it up and send it across the channel so that only Bob can unlock the box and look at the information. For Eve, it looks like something like a scrambled text. It will not make any sense to Eve. So this can be achieved. This is nothing but a secure communication which will be achieved using encryption decryption algorithms. This is so the foundation of secure communication is achieved using a set of cryptographic tools which are majorly motivated by mathematical techniques. There are also possible applications like user authentication, digital signatures. This set of applications belongs to the traditional cryptography, and there are many more modern day applications of cryptography, which are nothing but cryptocurrency. Also, in a loose sense, we can say it is like a Bitcoin, where uh, even though there is no governing authority to take care of the transactions happening, there is no way one can double spend a Bitcoin. There is no way he can spend the same coin twice. This is also achieved by the cryptographic tools. Also, secure storage and computation on the cloud. For instance, if you consider your health reports, which can be stored on an app, which again will be stored on a cloud storage, but yet you want your privacy. You don't want to reveal your health records to somebody else. Also, there will be some ML computation also happening these days on the healthcare data, but still, you should make sure your privacy is not compromised. Also, there are applications in the secure the distributed computing, where the one of the applications is e-voting. These things can be, and there are many more applications. These things can be achieved using the foundations provided by the cryptographic tools. So, consider a scenario where we have a secure crypto system at hand. Let's say encryption, decryption algorithm at hand. So, Alice have installed this. Alice is implementing this. Let's say popularly known RSA algorithm. Alice is implement. Alice is implementing the RSA algorithm on her machine and trying to send the data to Bob. So in this case, as indicated with this arrow, Eve has some access to Alice machine. Whatever the computation is happening on Alice machine, he can have a look. He can observe some data about that computation. So in RSA algorithm, there is a loop which is dependent on the secret key, RSA secret key, wherein if the secret bit is 0, there is some amount of computation happen and it will take some x amount of time, and if the secret bit is 1, there is some more amount of computation happening and it will take, let's say, y amount of time. As indicated in this graph, the amount of time it requires when the secret bit is 0 is less on an average compared to when the amount of computation happening when the secret bit is 1. So since the adversary having some sort of access to Alice machine, he can get this information. This is nothing but the time, execution time related information, so that he'll try to correlate this time information to decode the secret key, which ideally should only be known to Alice, but somehow Eve, by getting hold of this timing information, will be able to decode the key. So we would like to I would like to insist on this point. Even though RSA algorithm in theory is secure, Eve is using the information from the machine to decode the key. He is not breaking the RSA algorithm here, but he is using some additional information to decode the key. So even the algorithm is secure, it should also be implemented. The implementation should also be secure. So this is the attack model, side channel attack model we call, wherein along with the normal input output model, where the adversary will only know the ciphertext or also in some cases plain text, we'll also have access to the machine which is running the algorithm, so that he'll get a function of either the timing, like in the previous slide we have seen in case of RSA, or some power consumption, or so on and so forth. There are many side channels possible which he can observe from the device. So the ultimate goal of the adversary is to recover the key. So is there any way we can counterattack these side channels? As explained in the previous slide, there is a correlation which is there between the algorithm execution and the secret. If somehow we can make this, if we can somehow break this correlation, meaning even though the adversary is able to, it is impossible to stop the side channel leakage. It's even very expensive also in some cases to prevent the side channel leakage. So what we can do is, in a more cost effective manner, if we can break this correlation between leakage and the actual secret data, there is a possible, we can counterattack the side channels. And we also should make sure the cost required, as in case of HTTPS versus HTTP, there is an additional layer of encryption decryption happening on the data. So the encryption decryption procedure will take some additional amount of time and some additional amount of resources. So security will not come for free. Security will have its associated cost. But the aim of the researchers, Cocker et al. Demonstrated this dimension of side channel attacks in mid 90s. So from past 25 years, the researchers are working on side channel countermeasures. Also, we are working on making this cost as less as possible. From an end user point of view, we would like to minimize this cost of side channel security. So this is where my research is happening. So we will analyze how to build the countermeasures, also keeping in mind minimizing the cost associated with the side channel countermeasure. Making some trivial changes may not sometimes lead to the secure implementation. Suppose if I make a very trivial change to one of the side channel secure implementation to minimize the cost, it may lead to some other attack. So there should be a careful analysis of the security algorithms in order to minimize the cost. So my research is, as part of my research, focus is to minimize the cost, either in terms of like the normal algorithms, the time taken for the execution, or the memory required to execute the algorithm, or there are many other factors which can be considered. So far, we are successful to publish our work in cryptographic hardware embedded systems in 2020 and 2021. You can refer to the e-prints of this work. If you are interested, please contact us to get to know more about our work. So, what is the next thing I'm planning to do is, even though we are the security algorithms are designed keeping in mind minimizing the cost, the security proof associated with this countermeasure usually will be usually can be verified by a security expert, like the one working in the side channel area. But the device on which the countermeasure will be installed will be used by a end user, common user, which who may not have an idea about the research area. So the aim is to provide an automatic tool wherein if you feed in this countermeasure, secure countermeasure, along with some conditions which a person who has minimum knowledge about the area should be able to feed in, the tool must say whether it is secure or insecure, so that this will build the trust among the end users. So my next work is to design a formal framework using the formal methods from software engineering community to verify the to automatically verify the security of the countermeasure. And thank you for your attention. My colleague Shyam will continue with his research on cloud security. Thank you.
My name is Sham. I am a student under Professor Srinivas Vivek at IIIT Bangalore. I work on privacy preserving aspects in applications. Today I am going to talk about some aspects regarding privacy preservation in the cloud, namely cloud security. So today's talk will have some of the following contents. I am going to introduce the cloud technology and talk about the privacy in the cloud. And then there are two aspects related to privacy preservation, namely homomorphic encryption and cryptanalysis that I'm going to touch upon. followed by the work that we do in the institute. So cloud technology, as many of you might already be aware, is basically provision of resources, namely computation and storage in the cloud. Okay. So the most important aspect of the cloud technology is that it is accessible from anywhere, any location in the world, as well as be available 24 by 7 and 365 days a year. Basically, which means the ubiquitous availability of the resources. And because of its nature in terms of elasticity, meaning to say it can grow if your demand increases, or it can be decreased if the demand comes down. So it basically gives a very cost effective model for the users. And it also offers you a pay as you go depending on the usage model. And the other most important aspect is the management of the resources and its configuration. Okay. And there are many services that are offered by a number of providers. The providers actually are the big names like Amazon, Microsoft, Google, etc. And they offer services like platform as a service, software as a service, network as a service, and it's basically called IaaS, PaaS, etc., etc. The most important aspect is basically their provision of computation that is basically provided by these service providers based on their server farms that they have with them. So with this, comes the aspect of privacy preservation. What is the meaning of that? When you store your data in the cloud, you do not know what sort of guarantees in terms of security that these providers actually provide you for your data. Namely, the service provider may actually be interested to look at your data, not in any malicious or a bad way, but to be able to glean information about what is stored by you in their cloud. And there are other aspects in terms of there may be malicious or thefts, that actually may be wanting to steal your data. And you can also have a competitor, for example, right? Your competitor who may be wanting to steal your data for their own reasons and purposes, etc. So normally hospitals, big corporations, schools, and government databases are actually large places wherein the data is stored, which are actually liable for theft or some sort of a hacking, etc. Now we talked of one area wherein the cloud actually offers a large number of good features and benefits, and at the same time you also mentioned about the security concerns that are associated with the cloud. Then is it possible to have both these sit side by side, meaning to say provide the good features as well as save you from hacks and thefts, etc.? It is possible. And one simple way that you can think of is basically to encrypt all your data before storing it in the cloud. Fine, that will help you with the security aspects of it. But then we also mentioned about the computation capabilities that the cloud can provide. But because of the fact that the data is completely encrypted, it becomes completely gibberish. There is no way that any sort of a computation that can be provided by the service provider. Now, is it possible to have this as well? Yes, it is possible by using something known as a homomorphic encryption scheme. A homomorphic encryption scheme, while it allows for semantic security, which means to say that the data is completely secure, at the same time, it allows for some sort of a computation on data. I will talk about what is the meaning of computation in the next slide. But then what is the help that this computation will provide? By making use of such computations, we will be able to do searching, comparison, filtering, etc. on top of this encrypted data so that the results of these can be actually used by the user, without having to compromise on the security of the data. Now, what is the meaning of homomorphic encryption? I am not going to go into all the details of this homomorphic encryption, but I will just give you a very, very, very brief high-level overview of this. So if you know about the RSA algorithm, or maybe the Elgamal algorithm, or maybe the PAEA scheme, there are three different schemes that are there. There are many more schemes as well. Some of these schemes only allow for one operation, namely either addition or multiplication on encrypted data. However, a fully homomorphic encryption scheme allows for both multiplication as well as addition, so that we can make use of addition and multiplication as building blocks to build higher and more complex operations. So these operations, as I mentioned, searching, sorting, etc. But then there are other drawbacks that are there, and there is a lot of research going on in all over the world as well as our institute to be able to make use of better homomorphic encryption schemes that are much more advantageous and useful. Now, before I go into the details that will go into our work in the institute, I want to touch upon one small area known as cryptanalysis. What is the meaning of cryptanalysis? So this is basically analysis of protocols and algorithms in order to find any security faults or issues that are there in the algorithm. Okay, why is it needed? It is needed because when a protocol is designed, not every aspect of the protocol can actually be physically looked at by the inventor, right? And as I have written here, it is better to be broken by friends than by enemies, right? So if one of the people known to the industry, known to the academia, actually breaks the protocol, it will help in improvement of the protocol, so that when there is a large scale deployment of the protocol that happens, no security flaws can actually be figured out by anybody who is a hacker or an enemy. Okay. In the previous slide, in the previous presentation, Annapurna should have mentioned about the side channel attacks analysis and lattice-based attacks and analysis, which are also part of the cryptanalysis uh, topic. So there are many applications that actually make use of homomorphic encryptions schemes and other different encryption schemes that are actually used for privacy preservation. So namely, there are machine learning algorithms, and then there are many services actually, right? So there are ride hailing services and other services that are actually make use of the privacy preservation. So wherever there is an identity to be maintained, private information to be maintained, for example, hospital data or any sort of school data or government data, then we have to make sure that the security and the privacy of the data is to be maintained. In all of those places, definitely there is a need for such kind of privacy preserving mechanisms. So in our institute here, we look at primarily three different areas of work. Number one, we look at analysis of the privacy issues in different applications. The applications that we are focusing right now are ride hailing and ride sharing services like Ola, Uber, etc. We also look at analysis of recent works, in various different fields. In one example is that we have looked at one problem called the polynomial recovery in a machine language application. We also look at privacy preserving biometric based ID management, which is basically meaning like the Aadhaar kind of a scheme. And then we are trying to develop applications that actually make use of homomorphic encryption scheme to be able to fully preserve privacy of the users. We have in our group a number of positions that are open at different levels of in terms of MTech student level, PhD student level, as well as a few postdoc levels positions. You are more than welcome to reach out to us at IIIT Bangalore, or look at our website and get back to us. Thank you very much for your time.